All right, welcome to part 2 of the Parabola Graphs here lesson. Just keep blasting through these questions. Again, I encourage you to pause the video and give this a shot before watching the solution. Okay, so this one is talking about a rate of change, which when I think of rate of change, I think of the slope. So like on a traditional case, if we have a line, like the y will change, like go up so much, and that'll compare with the x changing by so much. So that like y change over x change, that's traditionally the slope. So on a curve, the rate of change or slope kind of changes. So the way they do it is like they try to draw what's called a tangent line, which just like touches it just once. And so that sort of gives you like the slope at this given time on the graph. So it's kind of hard for me to draw this out, but like these rates of change are going down. Like down here, the slope would be really steep if we thought of this as a line. See if I can draw this in a little bit better. And then here it would get a little bit less steep, and then get less steep, and then it gets up here, and it's actually just flat. So this slope of this, like if you think of these little lines running alongside of it, you could draw some down this side. You can see that the rate of change or these slopes are getting lower. Right, it's steep here, a little bit less steep until it gets to 0. So we say the rate of change is decreasing. Like basically how fast it's going up gets less. Right here it's going up fast, then less until it's not going up at all anymore of 0. So we'd say the rate of change is decreasing. And I should have pointed out they're really looking at between -3 and 0. So we're looking at this part of the graph right here. And we'd say the rate of change there is decreasing. Okay, again, pause the video, give this a shot. Okay, so in a parabola graph, all this is really asking is that this number in front determines if it opens up or down. So basically the number in front of the x squared, if it's positive x squared, it opens up, looks like that. And then if it's negative x squared, it opens down. So this one it says not moves up or down, whether it opens up or down. So that determines if the graph opens up or down, is that number in front. Okay, this one they give us a parabola, and our two variables here are like time in seconds, and then the height of this golf ball. And so all like flying objects like basketballs and golf balls and stuff usually fly through the air in a parabola shape. So I'm just going to kind of plot this here. We have time and height. I guess the time is x, but whatever. So basically, this is our y-intercept of 10. It starts there, and then it kind of goes up and then falls back down. And just like we were talking about, because this is negative x squared, it's going to be an upside-down parabola. Right, so it asks for the max height, we'd be finding the vertex, but that's not what it's asking. It says how long did it take it to land? And basically, that's a height of 0. Okay, so it's going to land right here. Okay, and so there's a couple ways to do this. One is you can just go to this equation and put in a 0 for h. And then you're just solving a quadratic equation, which you could do quad formula. You could factor, you could graph. But yeah, you're basically trying to find the number for x here that'll make this height come out as 0. Right, and so the way I'm going to do this, honestly, is I'm going to do my calculator. Because I think it's easy just to graph this and then look at where does it hit the ground, especially if these are my choices. The only tough part is we got to adjust our window. So the normal window when you graph on your calculator goes from like -10 to 10 on the x and -10 to 10 on the y. Right, but looking at my answer choices for x, I'm going to need it to go, I'm going to need it to go beyond 10. So anyways, let's type it in first and then we'll mess with the window. Okay, so in y equals, I'm going to do -5x squared plus, I think it was, what was it, 35x. Okay, and when we first hit graph, we might not see much because the graph, well, you can kind of see it a little bit. It starts at 10 and goes way up. And actually, we don't really need to adjust it that much. We can see where it's landing right there. Okay, and so based on my answer choices, the only one that even makes sense is 7. Right, so like this has got to be the right answer. Because 10 and 35 and all that stuff would be way out here beyond the graph. Okay, and just to show you again the window, if you want to see like the vertex is way up here. So we'd have to, not that this question asks that, but if you wanted to see, you'd have to change your window and change your y max. and I'm just going to kind of guess, and I'm going to change it all the way up to 100 and see if I can see the top of it. And there you can start to see it. So I could hit trace, like if I wanted to find the max height of this golf ball, I could just do that. But again, the one we really need is the 0 point. So, and again, we can keep tracing here if we really want to make sure it's 7, but based on the multiple choice answers, it's got to be a little more than 7, and you can see it there. That answer makes sense. Okay, so it's 7.27. Okay, so this is another when will it hit the ground? And I thought about not even including it, but basically you could do the same thing we just did. Just graph it, right? And this is a negative x squared, right? And figure out where it hits the ground right there. But I also thought like another way to do this is it'll hit the ground. That's like a height of 0. So if y is the height, we could just say, well, when does have a height of 0? When is y 0? And solve it. And so this one, certainly you can do the graph again, but I just thought maybe pause this. We could practice solving an x squared because there's an easier way to solve this than having to graph it. So maybe just pause the video and give it a shot. All right, so the difference here is this last one, you had both x squared and x, right? So you can't do algebra steps. But if you have just x or just x squared like this one, you can do algebra steps. And what I mean by that is basically just get the x squared alone and then square root. So I'm going to divide by minus negative 80 from both sides, then divide by negative 16, and the negative will cancel out here. I think that's just going to be 5, and then take the square root. So your answer will be the square root of 5, which is about 2 point something, like roughly 2.1 seconds. So again, this one doesn't show multiple choice answers, but if it was multiple choice, you know, we'd at least have a good enough ballpark of what it should be. So if you want the exact answer, just do root 5 on your calculator. Okay, next up, this one's a pretty advanced one. We're trying to find the y-intercept given that the vertex is at 1, 3. And the only hint I'm really going to give you here is that this is a point that's on there. So maybe pause the video and give this a shot. Okay, so the trick on this one is C is just where it crosses on the y-axis. So visually, you know, it's going to be like here, right? But it's pretty hard to like figure out that with a graph because we know where the vertex is. We know that that's at 1 and 3, so it'd be like somewhere here. But then where is it going to hit, right? Like, I don't know, we could kind of try to guesstimate. That's a horrible picture. Maybe I'll draw another one, but we could roughly try to guess at it. So I know it's at 1, 3 right here. And then I know it opens up, so it's got to hit, right, like somewhere around here, like 5 or 6 or something like that. All right, but the way to actually do this is not actually graphically. I think the easiest way is just to plug in y and x and solve it for c. So if this is a point on the graph, then we can put in 3 for y and 1 in place of both of those x's, and then solve this to figure out what does c have to be. Right? If this point has to be included on the graph, then it has to be a true statement here. So we need to figure out what number for c will make it a true statement. And then it's just algebra from here, right? So do PEMDAS, so do the exponent first. And then from here, multiply. So we'd have 3 equals 2 minus 4 plus c. And then 2 minus 4 is negative 2. And then add 2 to both sides, so c has got to be 5. Which kind of jives with what we thought, right? Like based on this picture, something around 5 would be a good guess. And on multiple choice, this picture might be enough to get you to the right spot, but if you want to know exactly, just plug in for x and y and then solve it for c. Right? And then that would allow us to complete our equation. Right? If we're trying to find the equation, we'd now know c and have our equation. Okay, I believe that is it. Thanks for watching.